Well, hello to everybody who's joined us. Thank you for participating and joining us in the GBF New Technologies, New Services webinar, sponsored by Connectivity Business News. I'm looking forward to having a great discussion with our panel here. I'm going to start by having each of the panelists introduce themselves and their companies briefly, and then we'll launch into some questions that I have for the panelists. And then we'll also have plenty of time for Q&A during the back half of the webinar. So I have with me Walt Anderson, the CEO and founder of Avealto, Brian Pemberton, Vice President of Sales and Marketing at Omnispace, and Christoph Bauer, Vice President of Commercial Sales at Astranis. So with that, we might as well just go in the order presented here. Walt, if you can start with your introduction, I'll have you kick it off.
Thank you very much. My name is Walt Anderson. I am the co-founder of Avealto, a UK-based company. We're developing a high-altitude or wireless internet platform that will emulate a satellite, but in the spirit of a new technology and new service, it is definitely both. And it has the best qualities of a new technology and new service in that it will be better quality and lower cost than existing satellite services, and will be serving underserved and unserved areas of the world and bringing people into the internet service that couldn't afford it previously.
Thank you. Brian?
Yes, hello everyone. Brian Pemberton, lead the sales and marketing initiatives at Omnispace. And we're a US-based company looking to deliver a global hybrid network where we're utilizing our global NGSO satellite network to interconnect with terrestrial networks to provide a ubiquitous connectivity experience for small, low-power devices, from mobile devices to IoT devices and everything in between. And so leveraging terrestrial-based technologies, but then adapting those for satellite operation and harmonization to provide the ubiquitous connectivity experience.
Thanks. And Christoph?
Hello, everyone. My name is Christoph Bauer. I'm the Vice President of Sales at Astranis. We are a US-based company located in San Francisco, California, in the heart of Silicon Valley. And we build and operate very small geostationary satellites that are fully digital, fully reprogrammable in space. We have a concept of software-defined radio, which means we are bringing to market very high throughput satellites for the size of a nation versus the size of a continent. The company is 6-year-old. We've raised $350 million to date, and we are starting to market aggressively our product at the four corners of the world. And we currently have signed 3 customers serving 3 verticals: broadband internet access for a customer in Alaska, connectivity for airlines with a customer called Anuvu in the US, and cellular backhaul for a customer called Andesat in Peru.
All right, thank you. In line with the theme of the panel, I think a great first question would be, what is the technology in the industry that excites you most for right now and maybe the next few years? Christoph, you just went, so I'll stick with you. You can say small geos and tell us why, or if there's something else, also be happy to.
Yeah, thank you, Kenneth, for the opportunity. As you can tell, we're very excited about what we're building at Astranis. The key today is that we're living in a digital world, and the satellite technology, unfortunately, has not kept pace with other technology areas such as the cell phone industry or even television, right? I think everybody watch digital television today. Everybody's using digital technology on our cell phone, and it's really key that the satellite technology keeps pace with those other areas. So the concept of going fully digital brings a lot of benefits, right? If you go digital on a payload like we have done at Astranis, you reduce the size and you reduce the cost, and you're also able to manufacture something faster and bring something faster to market that people want. All the customers I speak to nowadays all want to be able to reprogram their satellite after it's been launched in space. And they also want very fast access to market. The traditional geostationary satellites take a long time to build. As you know, Caleb, they take 3 to 4 years. It's a lot of CapEx investment upfront. And when we go digital and we bring new method of manufacturing satellites, at Astranis, we're building our satellites by batches. For example, we're building a batch of 4 satellites now that we launch in Q3 next year on a dedicated Falcon 9. So the concept is reducing the cost, bringing newer technologies that you can upgrade. This is really what we're all about at Astranis.
Okay, Brian?
Yeah, I think from our perspective, a really interesting, compelling technology is the new 5G non-terrestrial network standard, which is incorporated in the 3GPP release 17. It is the first effort that really looks to extend the global, mobile wireless standardization to the satellite or to a non-terrestrial environment. And we think this not only creates opportunities for many new use cases and applications, but also for the satellite industry to achieve particular economics and scale historically unattainable from proprietary solutions. So leveraging that technology, being able to deploy it on state-of-the-art satellite platforms and the flexible network architecture to not just reach millions and billions of users, but really address unique applications worldwide.
Walt?
Well, I'm looking at a human factor in that there's around 3 billion people in the earth that don't have regular routine access to the internet. And in the areas of the world that previously didn't have access, that have now got mobile phones and other access, there's been quite an increase, a notable increase in prosperity, human safety, rescue services, telemedicine, other things. So I'm looking at how to do that. And the tool that I'm using initially is high altitude wireless infrastructure devices. They've been talked about for many, many years, but until batteries and solar panels were more efficient, we couldn't build them. But now we can, and we can implement them. And they significantly lower the cost, and we're providing wholesale services to existing operators. So we're going to be able to allow mobile operators and internet service providers to extend their networks into areas where they couldn't before and charge a price that is low enough that a large percentage of the 3 billion unconnected can be connected, can afford to be connected. And that's, I believe, will have a significant factor on hopefully prosperity, but perhaps peace and knowledge in the world.
All right, now everyone here is developing a new technology, but Walt, I want to stick with you for a little bit because high altitude platforms or HAPs, I think you mentioned, have been studied and researched for a long time, but have never been commercially implemented. And it doesn't seem to matter how high profile the name is of the entity that's trying to make the technology work, whether it's Google or SoftBank or Airbus. It's not something that we've seen much more than technology demonstrators. So what is it that really needs to happen to transition this from a tech project to an actual business?
I think the first thing is that the people doing it have to pick the correct technology. Loon selected balloons and had a theory that you could control where a balloon goes by changing altitude. That doesn't work most of the time, and it took their management 8 years to figure that out. Of course, they were working for Google and earning nice salaries during those 8 years while they figured out their technology didn't work. Other companies were doing aircraft type HAPs. There are aircraft type HAPs operational now. The one the UK has is Zephyr, and it works, but it's not optimized for telecom because it can't stay in the same position in the sky. So a lighter than air vehicle, an airship type HAP, which is what we and other companies are developing, is realistically the option that will allow a large capacity of telecom to be delivered at an economical price. So we believe the first step is to pick the right technology from among the choices. And like I said, the batteries and the solar panels are here now at a very efficient level. So I believe this technology, its time has come. And that if we don't do it, the next guy in line is going to do it, and we're going to have HAPs operating around the Earth.
And when do you hope to have your first HAP in atmosphere?
Well, we're testing now with the CAA, the UK FAA, Civil Aviation Authority. We're doing initial testing. We're raising funds in the final step of raising funds to build a factory in the UK. We hope that within around 18 months, we will be operational in our first market.
Okay, thank you. Brian, you have one of your first of two prototypes that are now in orbit, and you mentioned the new 3GPP standard that is paving the way for the future Omnispace service. Can you tell us what you've learned from that prototype and what you hope to learn or need to learn in order to introduce a kind of service that wasn't possible before?
Yeah, the first satellite's only been up there about a month now, so the learning is still in the very early stages. But as we're looking to kind of the follow-on generation of on-orbit infrastructure, is really about solidifying the correct architecture in deploying the 5G technology, both on orbit and on ground, to enable that to scale to large volumes of users and across large geographical expanses. So our initial satellites will help us with that. We're also in the process of building out some lab infrastructure now to emulate the future environment and network architecture. Now that the 3GPP standard is nearly published, the infrastructure or the toolkit from the industry is becoming available. And so we're moving quickly to bring all of those pieces together to really nail down what that future, again, on orbit and on ground architecture and infrastructure looks like, and teaming with key industry partners to make that happen.
Okay. And are there going to be, you mentioned since it's a hybrid network, are there more technology tests or demos that you have planned for the terrestrial side?
Absolutely. So we have some of our own terrestrial infrastructure that we're deploying in Mexico as part of our CGC license there. So that'll become one test bed, but also working with some of the top mobile operators around the world to interconnect their network with our own to show that roaming capability for their subscribers into and out of or off and on the satellite network to maintain that connectivity for their end users. So we have a number of parties that we're working with and designing specific proof of concept testing, and we'll be working jointly with those parties for the next several months and years to prove out and demonstrate those technologies and capabilities to all parties.
Okay. Christoph, for Astranis, you're pursuing a small geostationary satellite. I think geosatellites, as they become reconfigurable, have gotten smaller in general, which the industry seems to look at as good news. But I'm curious how you sought the 350 to 400 kilogram size as ideal, and what technology hurdles there were to getting technology that usually fits in at least a 2 to 3 ton spacecraft down to something that's almost a rideshare size.
That's a great question, Caleb. But first of all, let me share with you how pleased I am to be with fellow panelists who are all believing in connecting the unconnected in the world. I think all of us have the same mission. We choose geotechnology for a reason, and that reason is that geotechnology is very proven. It's been around for a long time. We're bringing new advanced technology with software-defined radio, but we believe geotechnology is a good technology. It allows the reusability of existing ground segment. The architecture is open, the ground segment cost has gone down. And when you operate a satellite network, you have to take into account 3 things. You have to take into account the cost of the spacecraft, which we've worked very hard to bring down. you have to bring into account the cost of the ground segment, which is usually accounts for 30% of the total operating costs. And most of all, you have to account for the launch cost. And to answer your question precisely, one of the challenges we had is to make sure that we were not only bringing the cost of spacecraft down, but also making sure we benefit of ride shares opportunity and make sure we have the lowest cost possible for launch. And this is the very reason why we had the constraint to try to fit under 450 kilogram, which is the mass allowed on the ESPA Grande ring. The ESPA Grande is a ring where we can fit currently up to 4 of our macro geo on the Falcon 9 launch as a ride share. So being able to fit as a co-passenger and getting a very low cost access to space was critical in one of the constraints, which were to keep the satellite under 450 kilogram, which we have done.
All right. You mentioned trying to connect the world. I think this is a topic that the satellite industry has talked about a lot for the past 10 or maybe 20 years. But if you look at the data from the ITU, you'll see, I think at one point when O3b was founded, it was the other 3 billion that were not connected. Over time, that number actually grew to 4 billion. And then during the pandemic, it shrunk back down to 3 billion. People were forced indoors and there was a greater emphasis on connectivity. But a lot of that came from most of it came from the terrestrial sector, not so much from satellite or any of the technologies that are being discussed here today. So, Walt, I saw you nodding a lot. We'll start with you. What needs to be done so that companies in our industry are really contributing to meaningfully closing the digital divide?
Right. Well, it's a combination of things. In relation to terrestrial infrastructure, today, right now, the cost of implementing terrestrial infrastructure in areas with they don't have to be urban areas, but just areas with a reasonable high density of people is lower than it's ever been before per user. So there's an opportunity to make very relatively small investments and connect quite a lot of people throughout the world that are in areas that are open for that particular approach, terrestrial infrastructure, using wireless terrestrial infrastructure of various kinds. Another part is the fact that right now many governments around the world in countries that are what used to be called developing countries or undeveloped countries have begun to realize that this is a exceptionally good investment, perhaps the best, almost one of the best investments they can make in their future. And they're beginning to do that. So they've actually started making and supporting those investments. The final thing, and I think is what we believe, is that satellites have been around for a very long time, and they can serve critical infrastructure. For example, a government can afford perhaps to put a satellite on the top of a hospital and support that cost for telemedicine. But the government is not going to be able to afford to give satellite or support satellite for every one of their citizens or link the mobile network into a satellite because it just is too costly. So we believe that our technology, which is very much lower cost than satellite, wherever we go, we will be the lowest cost provider compared to satellite. We will not, there's no satellite service, GEO, LEO, MEO, that will be lower cost. It's just the nature of the technology we have. So we will be able to go in and serve areas that previously had limited satellite coverage, and now we'll be able to put service in place that will allow mobile operators to put their towers up and sell service at their currently, whatever rate they're currently selling, and extend their networks. And that's key. It doesn't take away from my two other panelists who have services that are adding value, tremendous value in the areas they're serving. So.
Thanks, Brian.
Yeah, I think your question there, Caleb, really hits at sort of the aspiration for the satellite industry for decades is to connect everyone everywhere. And that's heretofore, been unfulfilled. And my experience, I think a lot of within the industry would point to there's a willingness to pay for many of those parties around the globe, but not an ability to pay, especially for large, bespoke, expensive user devices that might be required from the satellite industry historically. And so that's one of the reasons that we're so enthused by the work at 3GPP around 5G, in that, the number of people that do have mobile devices around the world is substantially larger than those that have bank accounts or others. I mean, it is kind of almost the one uniform accessory that everyone has. And by now extending the reach of those networks to cover everyone everywhere, that even additional parties will be able to justify the value and the ability to invest in those devices and not just provide them basic connectivity, but as I think we can all relate to, smartphones are becoming part of our everyday life. The amount of utility they have, from banking to commerce, safety, security, weather information. I mean, there's an app for everything. And so, again, really kind of this standard and the realization of adapting standard-based technology that's already low cost, very accessible and affordable for users around the globe, and using satellite to extend that footprint to reach all users in all locations, we think is the first real step in the right direction to closing that divide and starting to serve those other 2 billion, 3 billion individuals worldwide.
All right. Thank you. Christoph?
Well, I'll tell you what our customers are telling us is that the reason why they choose a macro geo versus other technology is three things. They look at revenue, how much revenue they're going to generate with the technology. They look at the cost, at what cost am I going to regenerate that revenue? And they look at the customer experience, right? Those are three critical things. And from a revenue point of view, because we are able to come to market so fast, build a satellite and launch it in 2 years, we're able to assist customer to deploy and generate revenue extremely rapidly and access those people unconnected. We do it at a cost that we believe is very competitive. And we are also allowing our customer to set up that customer's experience with an onboard processor and a full software-defined radio technology that allows them to define different quality of service and assign a greater QoS for cellular backhaul, for example, or for government versus consumers. So those are the three criteria that really make it a success for us.
Okay. A question that maybe overlaps a little bit with the last one, but I still think is important for the panel, is that this is an industry that often gets very excited, myself included, about new technologies, but those new technologies sometimes struggle to become new businesses. So for each of you, when you looked at a tech breakthrough and then you saw a business opportunity behind it, what gave you the conviction that this would go and succeed in the market? And I'll just add to that. We've seen sensors, and because there's so much R&D that goes on in our industry, especially financed in part by government needs, that we do end up with a lot of really interesting hardware that sometimes works for a government customer well, but doesn't always translate to the commercial sector. So I guess with that in mind as kind of a backdrop, how have each of your companies pursued a commercial business, or how you looked at your technology and saw a true commercial opportunity with it? We'll start with Brian.
Sure, thanks, Caleb. I think, again, our leadership team is made up with individuals that have spent decades and decades in the satellite industry. So I think we have that experience as to where some of the pitfalls and mistakes been made in the past. And in our case, it's been about introducing a new concept, a new approach, not saying, here's a technology, how do I utilize it, but really saying, here's a market opportunity, here's a set of customers, and then work backwards to say, what's the right technology, what's the right business model that addresses that need. And a lot of times this industry gets a little enamored with the technical side and then looks for a customer solution. I think we're taking the opposite approach as we understand the customers their needs and how to address them and service them. And so then it really gets into what's the infrastructure and the right technology to be able to do that in scale. And then I think what helps, I guess, reaffirm or give us the confidence we're on the right path is not just the participation from the broader communications community, from the parties that are building the chipsets, the handsets, and other solutions, but really from the mobile operators that are servicing 5 billion users around the globe today, and seeing the interest and the enthusiasm they have in understanding how they're going to provide kind of the next value add or the next real benefit to their end users and their services. How are they going to provide that premium solution experience for their end customers, and really looking to the 5G NTN as a mechanism to deliver that. So I think that's why we feel so kind of passionate and confident that we're on the right path.
All right, thank you, Walt.
Well, when our team worked in other telecom companies before, and we were primarily competing with giant companies. For example, we went into the Spanish market. Telefonica is the largest company in Spain. When we competed against AT&T, British Telecom, we were always competing with giant monopolies. And the way we succeeded was providing a lower cost service, but also adding value by providing better customer service, more options, and sometimes higher quality in many cases. And so here in this instance, each HAP vehicle only covers a 150-mile, 240-kilometer circle. So we're not going to cover the entire Earth. Satellites are still going to be part of the equation, and we're actually working with some satellite partners to cover. But the areas we select to cover, we will be lower cost, and we will be lower quality. I mean, higher quality because of the primarily because of the latency issues. So we're able to look at an existing $26 billion market that's out there that is now provided by geosats only, maritime, a few mobile operators, some other services. And then that doesn't include the 3 billion unconnected. That's an existing market. So we see that there is a massive market, and we
Walt, I
just
think
have to select the optimum areas. We want to avoid an area that could become a terrestrial service area rather quickly, and find there never quite be up need of have the capacity of a terrestrial service area.
Well, thanks for your answer. I'm going to turn to Christoph now.
Yeah, sure, Caleb. Well, technology is never the business case in itself, right? Technology is an enabler to a business case. And in our case with the micro geo, we are giving full control of their business to satellite users. We're making it possible for large enterprise or small nation to have total and full control of their content and how they set up their business versus leasing from a larger geo operator. So that's one of the critical aspects of our technology. And also, let me repeat myself here again, but the fact that you can software upgrade those satellites and the fact that you can do very fast turnaround tech refresh will keep this technology at the edge for many years to come.
Okay. So for our audience, just want to remind everyone that you have the opportunity to ask questions. You can use the Q&A feature here on Zoom, and we will see those questions and are able to ask them to the panelists. So we've got about a half hour left, and certainly want to get to any questions that audience members have. So with that, I want to turn to the topic of 5G. Brian, I know this is a big focus for you, but I imagine for everyone here, the 3GPP standard that has been more inclusive of the satellite industry than previous mobile standards has to be good news. So how are each of your companies looking at 5G, and what do you see the role of satellite in the future ecosystem? Yes, Brian, I name called you or name dropped you, so we'll start with you.
Fair enough. Yeah, so again, the 5G and specifically the NTN component of it, basically, standardizing interoperability of a single mobile device between a terrestrial network and a satellite network is a huge transformation for both industries. The mobile wireless industry and has been focused on servicing as much as the population is feasible or possible, and that they can do economically. But that compromises much of the landmass. And especially with 5G, a lot of the focus is around enterprise applications, IoT, other types or M2M type solutions that just servicing the populated areas is not sufficient or is not adequate. So that resiliency, in addition to that expanded reach that can be provided by satellite is, we think, a huge differentiator. And so we think that the 5G standard, and as it becomes deployed from a service standpoint, and then also from a device standpoint over the next 2 to 3 years, will have a major transformative impact on those tactical and direct-to-device type applications and users around the globe.
All right, thanks. Walt?
Originally, the 5G standard as envisioned a number of years ago was a very, very high volume, low latency standard, but the satellite industry, in order to serve large portions of the world, they had to adapt it to allow much higher latencies. And in our business, we are a wholesale provider. And so we're providing services to mobile operators, internet service providers. So each HAP vehicle that we have can support multiple 5G link, sites on the ground in our service area. And so we found that a number of our potential customers want to add 5G into their towns and cities that they might serve, but in the countryside areas, they believe that 4G levels of capacity are still adequate for a service. We can support multiple 4G, 5G on our same vehicle, so it's not a problem to support both. But low latency is of value and does add some value to the customer because of forward error correction and other issues that make networks less efficient when you have a large distance between the transmission systems. And we think we are better at that because of the fact that we're closer to the ground. We're at 20,000 meters from the ground, which is 275 times closer than a geosat.
All right. Christoph?
I tell you, Caleb, we're very excited about 5G at Astranis. 5G for us means a larger amount of data to be transported from cell towers to the network, and in a lot of part of the world, in areas that are not well connected today, it will be satellite will remain the most cost-effective way, and also the higher quality of service way to provide that cellular backhaul. So this is a market we're definitely targeting in many parts of the world.
Okay, I realized that I picked on Walt earlier, asking him about timeline for his first vehicle, but I did not ask the same question to everyone else. So, Christoph, I know you guys have had some launch announcements. Can you just give an update on when your first mission is supposed to go up and your future plans?
Happy to do that, Caleb. Yeah, you probably saw the recent announcement we made at Space Symposium conference in Colorado Springs a couple of weeks ago. We announced the purchase of a dedicated Falcon 9 mission for our next 4 Ku-band satellites that we're building right now. We'll launch them all together in Q3 2023. And the first satellite dedicated to a customer that has been very patient with us, and we thank them for that, called Pacific Dataport for the state of Alaska. That satellite is scheduled to launch this summer. We have a launch date from SpaceX in August. It will launch on Falcon Heavy, direct inject to GSO, and that satellite will bring Ka-band connectivity to the entire state of Alaska.
Thank you. Brian?
Yeah, Caleb. So we just spoke earlier to the first of the two prototype satellites that we've launched about a month ago. The second one is scheduled on the SpaceX Transporter 5 mission here in the near future. And then we're looking to what follows that is on-orbit implementation and demonstration of the 5G NTN technology, which we're hoping to have in place by the end of next year. So moving very quickly in deploying that capability and working with some key industry partners for that technological implementation and demonstration. And from that, we would look to scale the network in low Earth orbit to start to target commercial services probably in the 2025 timeframe. And that timing is gated both by the timeline for the development and deployment of the constellation, but also the pace at which the commercialization of the products will be available. So the chipset manufacturers are still in their development phases. Once that's complete, they'll transition or make those commercially available to the device manufacturers, and then those will start to roll it out. So while we're looking to move quickly, we don't want to move so quickly that we have infrastructure there with absent customers in the early days. So we're somewhat pacing and gating our own deployments with that and the maturation and implementation of the broader device ecosystem.
Okay. Walt, I want to come back to you because you mentioned a couple of times a conviction that your service will be considerably cheaper than satellite services. Why is that?
Well, it's just the nature. I've been involved in space activities for a long time and promoter of space activities, but the cost of building a satellite and launching it is higher cost than our cost to put a lighter than air airship type vehicle into up to 20,000 meters. We can bring that vehicle down for servicing. In fact, we have to bring it down every 3 to 6 months to top up the helium. We put another vehicle up in its place so the customers don't experience a difference. It's just the numbers. I mean, the cost of satellites compared to the cost of building and maintaining our vehicle is different. And right now, the first vehicles we build will be the highest cost vehicles we build because we're learning how to do that. We're learning the manufacturing process. Our costs will come down as we build more vehicles. And I am convinced, absolutely based on my own experience in the space business, that there will be no satellite ever able to provide a lower cost service than us. But see, we're not really competing with the satellite industry. We're part of that. We could cooperate with a company like Astranis, and we are talking to other geo operators, where we could cover a large area where there are a certain number of HAPs covering the higher density areas, and the satellite covers all the rest. Now that brings the average price for that whole country, for example, down to a lower cost. The whole country's covered, the cost is lower, the satellite operator still has a business because they need to cover every little nook and cranny of that country, including the ocean areas in case they're near the ocean. We cover some high density areas, and everybody wins. So we're not an alternative to the satellite industry as much as a different part of that industry. But I am certain that we will be the lowest cost provider compared to any of the GEO or LEO or MEO satellites. But we're not going to cover everywhere. Even the sea lanes where we tend to put service over the sea lanes, there are going to be sea lanes that don't have enough density of use to make it worthwhile for us to cover. And again, satellite operators are going to take up the slack. So working cooperatively with them, we can give the best service to everyone and lower the average cost for everyone.
Who do you anticipate being your primary customer that you're going after? Are you going to be trying to sell to satellite operators? You mainly looking at mobile network operators?
Yep. Well, there are basically three categories. Mobile network operators are a huge market because they really, with the pricing plans that a mobile network offers, there's all you can eat pricing for a certain price. they really can't afford to have much satellite capacity in their network because it brings their average cost up. So we'll be able to provide service to a mobile operator that'll be within their cost point, so they could put a massive percentage of their network onto our service if needed. The next thing is marine operators. We do see some high density sea lanes that are ideal for coverage with a vehicle that can cover a 150-mile circle, and we just tile it along the sea lanes. The other thing is internet service providers in a lot of areas, Midwestern areas of the United States, Asia. There are towers where an internet service provider provides the last mile through a wireless connection. And in some cases, those towers are linked by satellite, which means that their prices are high. By putting a lower cost service into that tower, they can lower their cost by a huge amount and obviously get many more customers that are able to buy at their price point. So we see those three main markets: internet service providers, MVNOs, and mobile maritime operators. And we're talking to those guys. They're obviously, if you say to somebody, I can give you exactly the same thing you have now, because we're a terrestrial service, a number of countries are allowing us to operate in the KU band, the same band the satellite operates in, on a non-interference basis. So the ground terminals will not need to change. And they can simply point the antenna a different direction and get onto our service very quickly. With the marine operators, their terminals are already a flexible antenna that moves as needed. So it's a fairly transparent cutover to us for most users.
Okay. Christoph, the same question for you. Who's your target market? Where's your target customers?
Well, let me answer Walt first, because he said he'd be interested to work with Astranis, right? So I'll answer quickly on that one first, and I'll say we're not the ones who have to be convinced, right? The customers have to be the one to be convinced. And from my discussion with a cellular operator in particular, cost is not the only driver. Quality of service is also very, very, very important. And those are the markets we're chasing. I mentioned earlier, we're chasing the cellular backhaul market all over the world. We are also chasing internet service, broadband, point-to-point, point-to-multipoint, enterprise to enterprise, enterprise and government business as well. There are a lot of areas, particularly Latin America, Africa, and Southeast Asia that are seeing an exploding growth in a demand for connectivity, and the terrestrial build just cannot move fast enough. So the micro geo technology offers that benefit with Astranis, having a satellite able to be manufactured and launched in 2 years, and having the software-defined radio on board allows the customer to reprogram and reallocate bandwidth and power where the demand is. So if your business case evolves, if your demand change over time, we're able to accommodate that with our onboard fully digital technology.
Okay, Brian?
Yeah, our primary target customers are those users that require or desire mobile connectivity. So it could be consumers, retail users themselves. We're in conversations with a number of large OEMs, tracking particular equipment or heavy assets around the globe. But ultimately, we're looking to distribute to those end users through mobile operators and MVNOs around the globe. So we operate as sort of the infrastructure as a service. So we're augmenting the services capabilities and the infrastructure that mobile operators and MVNOs have available to them today, and then really targeting the types of users and use cases they would typically support.
Okay, so we have a few questions that have started to come in from the audience. So the first one, I think this is also oriented towards Walt. Are there any interference issues between GEOs and HAPs? Do HAPs have to go through the ITU coordination process?
Yeah. The first answer is yes, there are issues. And since we're coming in later than the GEO operators, we're the ones that have to be non-interfere. We're the ones that have to make sure we don't harm them or interfere with them. And the geosynchronous network along the equator is a satellite every 2 degrees. And so it's possible with the parabolic dish antennas to discriminate against interference between satellites every 2 degrees. So the location of a HAP, if we place the HAP in a way that the customer's pointing the antenna more than 2 degrees away from geo, the interference issues go away, except there's always a little area within our coverage area where we are directly, there's a direct line of potential interference. We call that the no-go area. In that area, we're either going to have to not serve customers in that little portion of our coverage circle, or we're going to have to use frequencies that are completely unused by the geo operators in that part of the world. And that may mean tiling more than one HAP to cover an area so we don't create an interference. We've gotten some people who are experts in this to write studies and determine exactly how we have to operate to not interfere. In terms of ITU, ITU is not a regulatory agency, but a treaty organization, and they do not regulate what happens inside each country. So if a country chooses to allow a terrestrial operator like us, because we're not defined as a spacecraft, to use a frequency on a non-interference basis, that's okay. The ITU obviously serves the people that use network right now. There are no HAPs operating, telecom HAPs operating today. So the ITU is not allocated any realistic frequencies, perhaps. They've allocated some frequencies in such a high level, like 70 gigahertz, 40 gigahertz, that would not work in tropical areas. And they've allocated such a small amount of bandwidth that we couldn't provide enough service to justify the cost of our HAP operation. So basically the ITU has told us to get lost. But the individual countries we're working with that have a need for our services, a compelling need, are willing to set parameters that we have to operate into, non-interference. And that's our goal. We don't want to damage the people that are going to be our partners and who are also providing service to customers.
Brian, Christoph, do either of you have any concerns about operating in a future environment that includes HAPs? Future spectrum environment?
Spectrum is always something that's highly contested, right? So there is some concern about people having to play by the rule like us and having to coordinate and people coming in and not having the same requirements.
Yeah, Caleb, from our environment, I don't think we see HAPs as a tremendous risk for causing interference. But there are some concepts of satellite operators operating using the terrestrial mobile bands, and we think that is that's certainly a challenge solution of how to avoid interference in those situations. And so we're very fortunate that we have our own licensed spectrum in which we will be operating in, and between that, the regulatory policies adopted in most countries for protection of MSS, we would be hopeful that we can avoid any sort of significant or harmful interference as we ramp up our operations globally.
Okay, great. I'm going to keep reading audience questions, which I think probably run us through the end of this discussion here. Another anonymous question: what are the most significant ground segment developments that are complementing your technology innovations? Brian, we'll start again with you.
I think from our perspective, again, starting with pretty much a blank sheet of paper for deploying a new infrastructure, the advancements in virtualization really look attractive and compelling. Deploying a global NGSO network where we're looking at hundreds of satellites, we're going to need substantial volumes of teleport locations around the globe. And so the ability to use virtualization techniques to scale those in time as we see demand from users and network utilization, but also to effectively be infrastructure light and be able to leverage services from cloud providers or others to scale that infrastructure cost effectively versus enormous CapEx outlay upfront is a big area that we see really attractive and compelling as we move forward.
Okay, just one follow-up there, because I don't know if Omnispace has ever quantified your constellation. You said hundreds. Do you have an exact number?
We don't have a number that we've published as yet, but yeah, to provide the types of service that would be desired or required and cover the Earth footprint that we're looking at, we know it's going to be multiple hundreds. Certainly not the scale of some of the mega constellations that are out there today with thousands. Will be well short of that, but it'll be still a fairly substantial constellation of very capable satellites to provide the direct-to-device services.
All right. Will you be bigger than OneWeb?
No comment directly, but we think in time, maybe you scale to that, but we certainly don't need to be there at the starting point.
All right, I'll leave it alone. Walt?
Well, we're using the same frequencies that geosat operators use, and in the same way, since we're in a stationary position, we're taking advantage of 60 years of technical development to make the ground stations more efficient, the hub systems more effective with the codecs that can put more megabits per megahertz. And we're using the same power levels. We're putting the same power levels to the ground as a geosat. We're not doing more, we're not doing less. We're equivalent in KU band to a high throughput satellite in terms of our EIRP to the ground. So we don't see any innovation in that field would be good, but we think there's some pretty sophisticated existing technologies for geosat operators to use on ground stations, and a lot of providers pushing the limits of what can be done with these radio capacities. So we're happy with what's there, and we can use it effectively.
Okay, fantastic. And Christoph? Christoph, you are still muted.
Sorry. We use an open architecture, so we want to be able to work with any ground segment service providers, and a couple of them we're working very closely at the stage of designing the network. We work very closely with Hughes, iDirect, and also with Gilat on a couple of project worldwide, and all those vendors have come up with new technology that are enabling better quality of service for cellular backhaul and others. So I think again, the symbiosis between geo and ground provider for geotechnology has been around for a long time, and we want to continue working, closing deals with those partners and having the opportunity to offer the best quality of service.
Okay, Christoph, we'll stick with you for the next question. This is from Israel Katz. Even though the question is about inter-HAPs links, I kind of want to expand it to all discussion of inter-satellite cross-links, which I think would be interesting to get everyone's perspective from GEO, from LEO, and from in-atmosphere. What do you view as the value proposition of cross-links for your company specifically? And do you think that there's a future where your spacecraft will have cross-links, whether they're laser or RF?
It's possible. I think there's a lot of benefits to having cross-links. The question comes always back to size, mass, and power, right? So it is difficult today with our size, mass, and power to add cross-links. Now, future generation, we leave the door open.
Okay, great. Brian?
Yeah, our view is that for any large scale NGSO network, primarily operating in LEO, ISLs or inter-satellite links are an imperative. That in our case, we're highly biased towards them. We expect those to be a key component of our next generation of on-orbit assets, and certainly our future commercial system. And it just yields a so much more cost-effective implementation of the ground infrastructure. It gives you so much more flexibility, resiliency, by having that effectively mesh network in the sky. Additionally, it opens up some really interesting applications and user groups that are very high value, that if everything's operating in a transparent mode or bent pipe, where the traffic is effectively being terminated where it's generated or close proximity, and that's, it really disqualifies certain applications and users. So the ability to offer a global solution, distribute that load of the users dynamically to support the capacity, inconsistencies on a daily basis or on a regional basis, and to be able to be more deliberate and cost effective in how you deploy your ground segment is, again, we think the investment in ISLs is more than justified by the benefits that it yields.
Okay. And then we have one final question, which this one was also anonymous, asks, the combination of GEOs, MEOs, mega LEOs, and HAPs would seem to provide masses of capacity. What is the ongoing capacity supply demand situation? So I realize everybody here has a slightly different business focus, but still, if you can kind of give your perspective from each of your markets, what do you see? Oversupply? Do you see a crunch? What's going on? I'll start with Christoph. Oh, sorry, or well, you started. We'll let you go.
I see the demand just continuing to grow and grow and grow and grow. I don't see any problem with the market and finding a market. So I think that there may be momentary spikes in different things where there's a problem, but as everybody here is talking about lowering costs, and that's good, and has accomplished that in some ways with their technology, that also improves the demand. So I don't think we're going to have any problem with demand anytime soon, anywhere in the world.
Yeah, I totally agree with that. In fact, at Astranis, we believe that you cannot put enough satellites up there, whether it's mega constellation or gigantic geo or micro geo. If you look at the history of the curves of data consumption, the more demand you put, the more demand there is. So we believe there will be an increase in demand for voice and data over the years to come that just cannot simply be satisfied.
And Brian?
Yeah, Caleb, to close it out, I think our view is similar to those the others on the panelists, is that demand right now is way ahead of capacity, and there's obviously many projects across the industry that are underway to try to rectify some of that imbalance. But I think the real question is, if we're unable to successfully open these new markets and new users and new applications, there will be a lot of capacity for the traditional use cases. And that's why we think it's so critical that the focus be on really kind of changing the market landscape of who the users are and how they're being serviced, to really put that additional capacity to utilization.
Can you just expand on that a little bit? What do you mean by kind of expanding the market in that way?
So historically, a lot of the satellite community, whatever their initial ambitions are, as the business develops, it ends up with government, aviation, and maritime as kind of the core applications and drivers, and those are the business units. And if all the new networks and technologies that are deployed are, don't reach beyond those user groups, that's a lot of capacity for, some finite markets, and really a lot of the demand for voice and data services are growing outside of those segments. I think, the panel here today has talked about many of those, from mobile users to different applications, IoT, mobile operators, et cetera. And so it's really going to be about how successfully the industry really taps into those developing user groups and areas and can successfully make a market of those. And there's more than enough demand there to consume the new capacity coming online.
Okay, great. It looks like we got one more question. See if we can do this one quickly, and then we'll close it. Thank you all for your inputs and technologies. One of the major problems facing satellite networks is interference. Are there any measures being taken to curb or minimize the problem while launching HAPs and Astranis? So, what are your companies doing to address interference? Let's start with
I'm
Christoph.
happy to start. We have an onboard processor that's fully digital, right? So we're able to identify a signal that does not belong there and simply nullify it.
Okay, and Walt?
We have this ability to track improper, interference with us, and we are, as I say, our location and the frequencies we use determines whether we'll interfere, and we'll be carefully selecting those things in a way that just from a technical standpoint can't provide interference.
Okay. Brian, I don't know if you had anything to add. You unmuted.
Yeah, no, I don't think I really have anything to add there. Again, we're operating in our own sort of allocated and secured spectrum band. So we don't, I think we live in a different spectrum environment than some of the broad solutions. Okay.
All right. Well, those are all of our questions. So I want to thank all of our panelists for participating. As a reminder, this webinar is being recorded and will be posted by GBF, I believe, in the coming days. So thank you all for participating, and I look forward to seeing everyone across the industry conferences.